Well, hello, everybody. Thank you for bearing with us through the technical difficulties. What we need is some artificial intelligence to help sort out the systems up here. My name is Jeff Welsch, and I'm here with my colleagues Mark and David. And we're quite excited to talk about Gemini Cloud Assist. I don't know about anybody here, but for me, it feels like we're on the precipice of something big. Right around the corner is the capabilities that will be enabled by artificial intelligence we've not even thought of yet, right? I think we're just starting to touch the art of the possible. So we're going to be, we hope, a demo-heavy presentation. We're not going to have much to talk about in slides. We just want to show use case examples. In full disclosures, we have animated GIFs here, but they are live recordings. We want to fit as much as we can into this experience as possible, so we wanted to make sure that we can just click through. So Cloud Assist, the reason that we have really been focused on building this is we believe, and we see in our customers, that there's a lot of time spent designing, learning about troubleshooting, trying to optimize environments, and less time focused on generating the business outcomes that are important to people. And so we believe with Cloud Assist, we're going to be able to help accelerate those processes and deliver on those business outcomes that are really the importance for why we're using cloud, et cetera. In the way we're going to organize this presentation, the way we think about Cloud Assist today is really about three primary pillars: a design, how do I accomplish simple resource creation, more complex compound resource creation, and how do I even think about deploying an infrastructure to meet application requirements? We have an operations mindset about how do we ensure that we can provide the best experience, the fastest time to resolution for troubleshooting issues, for example. And then, as I think everybody's interested in, how do we optimize our deployments? How do we improve our costs? How do we ensure that we have the best performance to meet perhaps unanticipated traffic spikes, et cetera? Or how do we plan proactively for expected increases in traffic around, Black Friday here in the US, or maybe an application going viral? So we'll organize the presentation into these three pillars. I'm going to start off with the design section, and then I'll invite my colleagues up to handle their sections as well. So let's take a simple example of a need to deploy perhaps a single web server, right? You want to build a web server that will, if I can see my slides here, that for hosting a web server with a simple VM, right? And you want to optimize for cost. So I want an inexpensive web server. I can do this by entering the Gemini chat, the Cloud Assist chat, and perhaps entering a prompt such as that. How do I create an inexpensive VM for running a web server? Now, what's going on in the background is Gemini is working to interpret my intent and determine if it has the information required to execute a command or tell me some guidance of what it can do. And in this case, Gemini has determined that it doesn't quite have all the information, but what it has done is understood I'm looking for an inexpensive web server-based VM. And of our virtual machine families, there's two that we would recommend: our E series, and just announced yesterday, our N4 series family that leverages the power of titanium. Now, because that's, I think, very cool, I can reply to Gemini and say, hey, I'm interested in the N4. And now with this amount of information, Gemini has the ability to tell me how I can accomplish my goal. So it's now taking this information, internalizing this, and has generated for me a G-Cloud command that executes the creation of a web server named Web Server 1 in the US East 1C region, which is what I requested, with its recommended 4 vCPUs and 16 gigabytes of memory. Now, with this information, I can copy this command and execute this in any terminal where I would like to execute it, or with our native Cloud Shell integration, I can copy this command over to Cloud Shell. And at this point, I can modify it. Maybe I don't want to call it Web Server 1. I can change the name or whatever it might be. And I can execute the command to generate that instance. So now with an instance up and running, I might also understand that I want to make sure I don't have any data loss. I don't experience any outage. And so I can ask Gemini for some support, not just to create virtual machines, but help me protect my instance by creating data backups on that virtual machine. Now, again, there's multiple options that Gemini can recommend. There's an entire virtual machine backup, or I want a snapshot on a regular schedule, which is what I want to do. Say every week or whatever it might be, or every day, every hour, I'd like to back up my volumes. So by replying to Gemini with the snapshot schedule clarification, Gemini can do the same thing. It can generate commands to tell me how to do this. But importantly, creating a snapshot schedule is a compound operation that requires multiple steps. And so you can see here, Gemini's actually provided multiple steps that I need to execute in order. to implement that virtual machine snapshot schedule. So not only can it create a simple resource, it can also create these more compound resources. Now, I think everybody here recognizes that you generally don't run an application on a single virtual machine. And so what we're interested in, perhaps in this use case, if I've got some new exciting application, is I want to generate a configuration that will provide auto-scaled load balancing with some firewall protection. I can also ask Gemini for support in that regard. So I can prompt Gemini with, generate Terraform, because I'm an infrastructure as code proponent and a fan of Terraform. So rather than G-Cloud, I'd like to have Terraform code generated for me to create an auto-scaling profile that includes a load balancer with some firewall rules. Now, it's important to note that the process to create this load balancer with this configuration is not 3 G-Cloud steps like snapshot schedules. It's actually 11 of them. So it's a very complex operation. And it involves creating an instance template that defines when a new virtual machine is created. I want to ensure that it matches that web server configuration. It involves creating a managed instance group. Whoops, sorry, wrong button. That actually generates the ability for us to manage the instance group at scale. And so when that Terraform is generated, I can create that, add that in my development pipeline, however I'd like to handle it. Now, on top of individual resources, Gemini can also help with application architecture design and deployment. So in this example, I've asked Gemini for guidance to deploy a 3-tier web application. Now, Gemini can identify, in this case, a jumpstart solution that defines a topology that meets this need and recommend it to me. By clicking through this and hitting the deploy button, Gemini will actually start the process of deploying this jumpstart solution with some customizations by myself. Right, if I don't have any of these APIs enabled, it will enable those APIs for me and begin deploying this. Now, this is actually where we start to see the convergence of Cloud Assist and Code Assist as well. Right, so in the background, Gemini and Jumpstart is deploying this entire application. And when it's deployed, I can continue to customize this complex deployment in Cloud Shell and our Cloud Code IDE. So what happens here is the environment is provisioned. My code is actually being, the repo is being copied into my deployment environment. And now I am able, with Cloud Assist, or Code Assist, I'm able to start to begin to edit the code. So I can open up the code, and for example, just as a use case, this is a Redis-based deployment. I might be interested in understanding what this section of code actually accomplishes. By highlighting code, Code Assist can help me explain the code and translate that code into natural language to tell me what it actually accomplishes. And then I can ask for some improvements as well. So you can see here, Gemini has translated that code into some descriptive text. And then I can generate unit tests, right? So Gemini will take this code, my custom code, or this Jumpstart solution, and help generate unit tests to ensure that my code functions properly. Now, I can also, if I'd like to, ask Gemini to help me modify this code. So in this example, Redis was initially configured with 1 GB of memory. Perhaps I'd like to change that to 4 GB of memory. Gemini can understand, because it understands my code, it can generate the improved or the modified Terraform and allow me to insert that into my code base. And so now, after deploying this environment in my CI/CD pipeline, redeployment will actually apply that change from 1 to 4 GB of memory. So I think it's important to understand with Gemini, with Cloud Assist, we're just scratching the surface on design and architecture and understanding the context and the intent that our users need to build out their applications. Over time, we're going to see this capability continue to improve substantially. So I'd like to introduce now Mark Church to talk about some operational capabilities of Cloud Assist. Thanks, Mark.
Thank you, Jeff. So I got to say, we had a little snafu with the laptop up here. And there's nothing like a simple technology issue like that to make you feel artificially intelligent. So just a reminder that technology can be an enabler sometimes, but it can also be humbling as well. So I'm going to talk about, I'm a product manager within Gemini Cloud Assist, and I've been focusing on operations and troubleshooting. And so this is kind of the area where how do we do interactive, proactive troubleshooting? How do we reduce the timeline of incidents? How do we detect problems earlier in their life cycle? So let's play through some scenarios, and we're going to walk through the features that we have. So let's say I'm an application owner, and it's Friday afternoon, and someone from my team has inexplicably, or have found an inexplicable latency issue that's occurring with our app. I don't know, the network team maybe has left already. I know how to troubleshoot my application, but maybe not the infrastructure as much. But I do hear that Gemini can help me with automated troubleshooting. So let's give that a try. So what we're going to do here is we're going to ask Gemini, can you troubleshoot this symbol shop service latency issue for me? Just take a look. And then let's see what Gemini does. Okay, so it's already come up with an answer here. We can see it's found that latency is correlated with QPS. That's interesting. Looks like traffic is somewhat evenly distributed across the backends. It says here that the symbol EU2 has a significantly higher than average backend latency. That's also kind of interesting. And so it's giving us kind of assessment of what it thinks is happening. And it's saying, well, you could have some sort of a capacity issue going on with this specific application backend. So we now have a breadcrumb. Let's talk about what is happening under the covers. So in the Cloud Assist side for troubleshooting, we have a playbook style approach for troubleshooting in which the language model detects what kind of playbooks are relevant to this specific issue. It executes them. That creates insights for us that the language model can then use to assess what might be happening. And so that gives us a breadcrumb and helps focus our efforts and focus what we're looking at to get to a root cause faster. And so this is, very helpful for a lot of scenarios, right? We can reduce the timeline of issues. We can shift troubleshooting left, so the application owners and non-infrastructure people can, be more approachable for these kinds of issues. So let's continue on. I think it's also very important with technology like this, you trust, but you verify. So let's actually have Gemini check its own work. So we're going to ask it, show me the P95 latency of the symbol shop service, and let's break it down by backends. Okay, cool. So what we have here is we can see that Gemini is showing us that we do actually have a lot higher latency with the symbol E2 backends. So clearly there's some sort of outlier happening here, and we've got some sort of spiky latency happening. Let's look at the requests per second of the same service group by backends to see where we are at. And it looks like we have two very different traffic patterns. And so what's happening here is Gemini is taking my natural language queries, converting them to PromQL, and then executing them. I can click that button, this would pop out to CloudOps, and then I could see the query in the native interface. But as a non-expert, this is very helpful. It makes it much more approachable to understand what's happening in my environment. Okay, let's dive one step deeper now. Technology. And let's actually ask about capacity. Let's ask Gemini if there's any capacity or quota issues happening in this specific region. And then we can see right away, Gemini has found a specific error log that points to an exhaustion, a quota exhaustion issue for CPUs in that specific region where the backend was. So this could point to maybe quotas were configured incorrectly in that environment. Maybe somebody deployed something that exhausted the quota and we weren't aware of it. In any case, it gives us the link to go investigate further. And this is kind of also an example of the playbook style troubleshooting in which it used various playbooks related to quotas and capacity to kind of narrow down what's happening and found a log entry that was relevant to this issue. So this is only 5 minutes of troubleshooting. What do we accomplish here? We identified some relevant trends and patterns, right, that were relevant to the original query issue. We validated its work using raw data, and we also found the needle in the haystack that we were looking for. And so this is a very powerful model in terms of addressing all kinds of problems. So let's take a little bit about kind of under the covers here. So we're essentially doing some sort of orchestration. We're orchestrating playbooks together. We're first identifying the intent of what the user is trying to do, right? This is a troubleshooting style query. We're determining the right playbooks. Those playbooks may be a combination of probabilistic code, so LLM calls, or deterministic code that might be detecting certain scenarios or cases in that environment. And then we're summarizing or aggregating that result into somewhat of a root cause. And in the future, this might be an iterative approach too, so we can automate it and go deeper on its own. So let's take another couple situations here. So in this scenario, we have, let's say we have on-prem clients that are coming in, they're connecting through a load balancer to an application, and that application is hitting GCS as a backend. So we have a connectivity issue. And so let's ask Gemini, hey, we're having a connectivity issue. Can you help us troubleshoot what might be happening here? And so we're going to say, well, I can't reach the load balancer. Can you take a look? Okay, and this is an example where this kind of shows some of the conversational aspects here. It's narrowing down, helping scope the problem. Sometimes there's a minimum necessary information it needs to help do something, right? And so it's asking, well, where are you trying to connect from? And this is an area where we're enhancing its conversational ability so that it can handle like a wider variety of situations. And here we can see that it's unreachable. And it's actually blocked by this specific firewall rule. This is a similar demo that we did in the keynote today. This is an example of tool use because we have a connectivity test. And so Gemini is actually generating the command to execute that connectivity test. It's getting the required information and then summarizing the result for us. So, and there's many tools in GCP, and so there's a nice example. So on the side, let's say I remove the firewall rule. And so let's ask Gemini to run this connectivity test again. And we can see that Gemini says, well, ran it again. Now it's reachable. Problem solved. So this is a case, let's say now we're having issues connecting to GCS. So traffic goes through, but for whatever reason, we get a specific error when connecting to GCS. Looks like some sort of a 400 level error. So we paste that error in here that we saw in our cloud logs. And again, Gemini is using a playbook around GCS access issues and identifying, well, here are some IAM permissions that you're missing in this case, for this particular service account. And here's the command you can do to add the IAM permissions for that service account that would allow you to do this type of operation. And so this troubleshooting based approach is very flexible and dynamic to a wide array of different types of problems. Now let's say we have maybe a capacity issue on our interconnect, and we have a lot of traffic coming through, and we maybe want to find who are the top talkers across the interconnect. Well, something called VPC Flow Analyzer was just launched, which provides the ability to break down VPC flow logs in a visual way and play with them in a very easy to use and easy to understand manner. And so here we've recently added the smart query. So similar to the PromQL queries, we're going to ask a question here. Show me the top talkers over my interconnect grouped by on-prem IP. What we really want to find is who are the top users, the top offenders of kind of the usage of the interconnect here, because it's a precious shared resource. And then we can go talk to those teams and find out kind of who's using the capacity. And here we have it broken down. And so this is now translated our natural language query into a SQL query that is appropriate for the tables that contain VPC flow log information. And so I just want to end on a couple notes. One is that we're really building a lot of foundational building blocks here. So this is showing examples of interactive troubleshooting, but you can imagine where this goes in terms of proactive troubleshooting. We can hook up alerts and proactive triggers to this kind of thing. And then you have a very kind of general purpose workflow engine. You can trigger automated troubleshooting, and then the output of that automated troubleshooting can go into a different system, and that can be viewed by an SRE. And so these are fundamental building blocks. We are early on this journey, but we've already shown a lot of promise of being able to address a wide array of situations. And so I am very excited and bullish on what we're going to be able to build here. And so with that, I'll introduce David, who's going to take us through optimization. Thank you.
Thank you, Mark. Hi, everyone. My name is David Cheng, and I'm going to show you how Gemini can help your organization optimize your cloud infrastructure. So when we think about cloud optimization, we've been exploring 4 different areas around cost, performance, reliability, and security. And the one thing that, as we've been unpacking these areas, that we found is that the magic really happens when Gemini is able to take your relevant workload context your application settings, your infrastructure configurations, and match that against specific Google Cloud knowledge. Everything from reference architectures, best practices, down to support playbooks. And so to highlight this, we're going to walk through a few examples, starting with cost optimization. And conveniently, Alex is back, and he wants us to take a look at cost optimization for the new VP. So let's see how we can do that with Gemini. So the first thing that we might do is start to look at low-hanging fruits. The idea here is to show how Gemini can go broadly across different infrastructure domains, compute, networking, storage, and summarize some of the maybe more no-brainer recommendations. Here we should expect to see things like idle disks, unused IP addresses, idle VMs, right? And I particularly like that Gemini is summarizing the payoff on the right so that you can prioritize. And if we wanted to, we could investigate further here. But perhaps we want to go in a different direction. Maybe we want to look at something a little more complicated, a little bit more nuanced. I heard from the database team recently that SQL Server costs are getting a little out of hand. So let's see how we can explore that. So what we're going to see here is that Gemini, with context of which VMs are running SQL Server, are going to provide relevant information and suggestions for how we can optimize our cost. You'll see an example here around simultaneous multi-threading that helps you get more cores more performance out of your cores. You'll see another example of 4-core consolidation right at the bottom. This is Microsoft charges 4-core minimum. And so the idea here is if you can consolidate some of your smaller VMs, you can also save on licensing. And there's some trade-offs here. Let's drill down a little bit further. Perhaps we want to explore simultaneous multi-threading a little bit further. And so the idea here is that, again, Gemini is going to provide relevant context and show us which VMs should be considered for simultaneous multi-threading disabling. You can see the instances, the zones, and additional machine types. I think one of the things that I'm trying to show here is that Gemini allows you to peel back the layers of the onion so that you can actively analyze the data so that you can make optimization decisions quickly. One of the things that I think a lot of customers tell us about is the round trip where you have to work with your ops team, work with your infrastructure team to get the data. So here it's an example of how you can quickly get that information. Let's say with this context, we can identify that these are all internal VMs and we want to go ahead and make the change. So to close this specific demo out, we can ask it to generate the code for us. So let's see this. All right, so here you're going to see a bash script that's going to be pulled up, and it's going to include the VMs 100 through 104. You're going to see some scripting that's G-Cloud commands that you can then copy and paste. And so again, what I particularly like about this illustration of cost optimization is just how actively you can analyze and wrestle with the data using Gemini in a fast way. One aside that I think is relevant also on analyzing data. This is an example of networking if you wanted to identify VMs with inter-region data transfer costs. And if you don't know how to do that in a second, this could help you, right? So you could pull up, it's going to generate a query for you that's going to pull all of the VMs that have inter-region data transfer costs. You can execute this. And then if you wanted to, you can then ask it to summarize this information for you. And so the purpose of this illustration, again, is just to show how Gemini can serve as an accelerant in your optimization journey. I'm going to switch gears for one moment here and look at reliability optimization. And for this example, I'm going to pick something fairly specific around SAP. And the notion and maybe the motif behind this demo is just how specific Gemini can get for your analysis. So here we're going to help us optimize SAP reliability. And it's going to give us specific examples on here are the recommendations, right? Everything from setting maintenance mode, updating your timeout settings, going all the way down to max messages, which can improve cluster stability. Again, I know we're being hyper specific on these details, but I think the point of this section is to just show how Gemini is able to take specific playbook knowledge and tee that up with the right context of your deployments. From here, we can drill down further. Maybe we want to look at max messages here at the end. So we're going to ask it for follow-up questions. And what this will do, Gemini is going to then dig a little bit further for you, and it's going to surface up the relevant VMs. And you can see max messages are set to 10 for these VMs. And it's going to say, hey, your best practices are going to recommend that you set it to 20, right? And again, this is an example to highlight how Gemini is able to get the specific context, match it against the specific playbook recommendations all the way down to the ground floor, and then pull that back up for you in a fairly interactive manner. I think the last part of this demo is just to show how you can also generate recommendations. And the reason why I want to show this example again is what you're going to see is Gemini is going to be able to pull in and recognize that depending on which operating systems you're running, it's going to give you the right commands. So here we're going to ask Gemini, please generate the code for me to update max messages. And then Gemini, with the specificity needed, right? The details matter in generating the code. You're going to see it says, hey, I can see that you're running SUSE Linux, and it's going to give you the right commands. Instead of the Red Hat commands, you'll get the SUSE Linux commands. And so to kind of close out on these two demos, I think the idea here is the level of specificity. We believe it's unique in what Gemini is able to provide in terms of how you can optimize your workloads. And so I'm going to close out in this last section. The first, in the beginning, Jeff kind of walked us through how you can modernize and deploy modern applications quickly against complex business requirements using Gemini. Then Mark walked through how you can operate and run and troubleshoot your applications easily and efficiently with Gemini. And then at the end, we were able to take a look at how you can optimize with the right level of granularity and specificity using Gemini, going all the way down to the playbooks. And so to kind of close here, these are very exciting times. We are very excited to be here with you all, and we are very excited for you all to try Google Cloud Gemini Assist. So thank you very much for y'all's time. There are a few, there's a few slides here in terms of please give us feedback. There's a few other sessions on Gemini coming up that if you want to take a look at it, highly recommended. So, and we'll be at the front for any questions and Q&A. So thank you all for the time. Hope you have a great afternoon.